You understand the value of utilizing log agents such as Fluentd or Fluentbit, but maintaining those log collector architecture could be complicated, especially when you need to regularly update your logstream pipeline. If you're trying to manage your pipeline in a smart way, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Kubernetes series, and in fact, it's also part of the logging series. We already had in the logging series several episodes related to logs dedicated to several solutions. So we had Fluentbit, Fluentd, several episodes, in fact, on Fluentd, Loki, and recently Stanza. Today's episode will be focused on explaining the value of the Fluent Operator. You will see that it will help us to deploy our agents and manage the maintenance of our pipelines. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We will start with a brief introduction related to the log agents, Fluentd and Fluentbit. We will then explain the concept related to the Fluent Operator, and you will see it introduces new CRDs, so we will have to touch base on them. So first, all the CRDs related to Fluentbit, and then all the CRDs related to Fluentd. We'll then jump into sharing few best practices, and last, like usual, we will jump into a tutorial. Fluentbit and Fluentd are both log agents able to collect, filter, parse, and forward log stream to any observability backend of our choice. The major difference between both solutions is that Fluentbit is lightweight, so more efficient to collect and parse logs, while Fluentd, on the other hand, has the advantage of having a very large number of plugins that help us to transform, forward log streams to any solution of the market. So at the end, we probably want to use Fluentbit to collect and do most of the tasks of our logstream pipeline, and then utilize Fluentd to finalize the transformation of our logs by doing advanced processing and then forward the logs to our preferred solution of our choice. In our previous episode related to Fluentbit or Fluentd, we saw that the log agents could be deployed in various ways, in a bare metal technology environment or within the Kubernetes cluster. Both solutions requires to build log stream pipeline describing how we want to collect, to process our logs, and then of course forward. The pipeline of Fluentd or Fluentbit are stored in a configuration file. In case of Kubernetes, it would be, of course, in a config map. So at the end of the day, operating Fluentd or Fluentbit requires to first manage the deployment of our log agent. They are usually deployed in Kubernetes using daemon set. And then also we have to build our pipeline and updating the various log stream pipeline by modifying the config map. The major disadvantage working with config map is that we need to restart our various Fluentbit or Fluentd pods to be able to take advantage of the recent updates made on the pipeline, the config map. The other big pain is when we start combining Fluentd with Fluentbit. Then it means that we need to manage our updates from both products and then handle them in the right order. So if you want to find a solution, simplify the maintenance of your log agents, you should be very interested in the Fluent Operator. The Fluent operator will allow you to manage the deployment of either only Fluentbit, or if you want to combine Fluentbit and Fluentd, you have the options to combine Fluentd and Fluentbit. Like explained, you may want to use Fluentd in certain situations to do advanced processing on our logs. At the end, the operator will deploy Fluentbit in a daemon set to help us to collect logs from our cluster. On the other hand, Fluentd will be deployed as a stateful set to finalize our logstream pipeline. The operator will come with several CRDs to manage the Fluent Bit and Fluentd deployment, the configuration that will link the various steps of our logstream pipeline, and you will see that the steps now will have dedicated objects, so you'll have to define the input steps, the parser steps, the filter steps, and the output steps. That means that we are not going to design our pipeline in the same way that we used to do with Fluentd or Fluentbit. It will be done differently with the help of those new CRDs. The operator introduces the new object, so the Fluentbit. So the Fluentbit object defines the Fluentbit deployment, the daemon set, and the related configuration. You can use a custom Fluentbit image, but keep in mind that the default one is CubeSphere Fluentbit, and it's not a standard Fluentbit image because it requires to work with Fluentbit operator to handle the reloading of dynamic configuration. So here is an example of a Fluentbit object. As you can see, you can also customize the image and specify the request and limits of your agents. The Fluentbit deployment will refer to a config that holds the logstream pipeline. In the case of Fluentbit, the configuration will be defined at the cluster level with the help of an object called cluster Fluentbit config. You can limit the scope of your pipeline by specifying a namespace field. But if you don't, it will be basically on the entire cluster. So here is an example of a cluster Fluentbit config. As you can see, we map the various steps of a pipeline using label selectors. The cluster config will attach the logstream steps in with the help of label selector. Those labels will need to be specified on each Fluentbit object describing our pipeline steps. You will see that later for the cluster inputs, the cluster filter, and so on. So you will need to define how to map your input steps using the input selector, how to map your filter steps using the filter selector, and of course, same thing for the parser steps and the output steps using the output selector. Each steps of the pipeline will then be split into big steps of your logstream. So input by creating a cluster input object, parser by creating a cluster parser object that could be either alone or be called through a filter task as well. A filter steps with the help of a cluster filter, and last, a cluster output for any output operations. The operator watch the various objects, so Fluentbit, the cluster Fluentbit config, the various steps, so cluster input, cluster output, cluster parser, and so on, that we have defined on our pipeline, and will create secrets with the changes that we have made on our pipelines containing actual logstream pipeline. The daemon set that has been freshly deployed will be referring to those secrets. The way of defining Fluentbit pipeline would be slightly different to what we used to have. So this is a Fluentbit traditional pipeline. You can see we have dedicated section for the input, for the filter, for the parser, for the output, and so on. Now, each block of this pipeline will represent a specific CRDs. For example, we will have a cluster input like this, where we basically use an operator tail to collect the logs from a cluster. We can then use a cluster filter like this, and we will have a list of steps to do the various changes or processing that we need in our pipeline. And last, we use a cluster output settings like this if you want to send it, for example, in our case, in this example, to std-out. The great thing is that every update made on each of those CRDs will automatically update the Fluentbit agents running. As of now, not all the Fluent Bit plugins are available in the Fluent Operator, but we could expect to have more plugins in the near future provided by the community. Similar to Fluent Bit CRDs, Fluentd has the similar logic. First, you need to create a Fluentd object that will specify the deployment of your Fluentd agents. The major difference with Fluent Bit is that you will define in the configuration of your Fluentd deployment how you are going to receive logs for your own Fluent Bit pipeline. Here is an example of the Fluentd settings. As you can see, we are specifying a global input where we are going to receive the forward streams on a specific port. Similar to Fluent Bit object, you can customize the image, but keep in mind that it's a specific instance of Fluentd designed for the operator. The Fluentd object needs also to have a configuration object. In the case of Fluentd, we have two ways of configuring it, either at the cluster level with the help of cluster Fluentd config objects, or at the namespace level using the Fluentd config object. So here is an example of a cluster Fluentd config, and as you can see here, we can even at the cluster config, we could basically limit the scope of our cluster, of our Fluentd in fact, to specific namespace using the watch namespaces parameters. Similar to Fluent Bit CRDs, you will map your pipeline using the label selector. Because Fluentd acts as a log forwarder in the Fluent Operator, you will only have filter and output steps available. So the idea, like explained, we will collect, parse, filter the logs using Fluent Bit and then forward it to Fluentd to take advantage of specific Fluentd filter plugins or output plugins. That is the reason why Fluentd has only the following pipeline objects available. We have the cluster output or output. So cluster output needs to be used with the cluster Fluentd config, and the output, of course, with the Fluentd config. So the cluster or the output object will be there to define the output steps of your Fluentd pipeline. So here is an example of a cluster output object, where here we basically send it to Elasticsearch. At the moment, the operator is not allowing us to add existing plugins. The operator supports the following output plugins for Fluent Bit. We have Datadog, Elasticsearch, File, Firehose, Forward, HTTP, Kafka, Loki, std-out, syslog, and TCP. For Fluentd, we have only the Elasticsearch plugin, the Forward, HTTP, Kafka, S3, and std-out. In the case of traditional deployment of Fluentd, we can simply provide a new Docker image having our plugin pre-installed in the traditional Fluentd image. In the operator, it's a bit different because we rely on those CRDs. Our pipeline at the end of the day are defined using the various CRDs available, cluster input, cluster filter, cluster output, and so on. So providing a new image won't help us because the CRDs needs to be also updated by adding the new definitions of this plugin. Therefore, if you need a specific Fluentd plugin, I would recommend to deploy Fluentd manually basically not managed by the operator, and configure Fluentbit pipeline to forward the log stream to your custom Fluentd deployment. When it comes to designing your log stream pipeline, I would clearly recommend the following process. So define your inputs and only utilize first the std output. Look at the produce logs in the Fluentbit pods logs, and then add several filters and validate your changes by looking at the logs of Fluentbit. I would recommend to do small changes and validate them one by one. It would avoid you to building complex pipeline and spend a very large amount of time debugging your pipeline. Small tips that could save you a lot of time. The regex parser used by Fluentd or Fluentbit are based on Ruby regular expression. If you want to test your regex expression in a more efficient way, I would recommend to use the following website that will allow you to copy-paste an example of a log stream, put your regex, and that will help you to at least validate that your expression is working perfectly. In this tutorial, we will deploy the Fluent Operator, configure and design a pipeline that will help us to collect logs from our pods in a cluster and then send it to Dynatrace. In this tutorial, we will have several requirements. So first, like usual, we will need a cluster with 1 or 2 nodes, at least 2 nodes. Then we will deploy nginx because we will need to create an ingress rule to make our application available out of the cluster. We will have to deploy our demo app, which is the hipster shop, the online boutique. We will utilize K6 to generate small traffic on our cluster just to help us to generate logs. We will deploy the Prometheus operator because K6 utilize the Prometheus plugin to write statistics in the Prometheus time series database. Of course, we will deploy the Fluent Operator. And last, we will need a Dynatrace tenant and a local Dynatrace active gate to be able to send our log streams to Dynatrace. In this tutorial, we will first deploy a pipeline and use std to see our changes. Then we will apply few updates to be able to send our log stream to Dynatrace.
Like every tutorials that we deliver at Easy Observable, there is always a GitHub repository related to this episode. So here we're looking at the repository related to the Fluent Operator. So we are not going to go through the steps to deploy all the various components, but let's remind the various requirements that we already explained in the video. So you need a cluster. So in my case, I use Google Cloud. You can still do it with Rancher or other cloud providers or locally on your laptop. But you need a cluster at least with 2 nodes in minimal. In this repo, there is a specific file to deploy nginx ingress controller. So make sure you have deployed your ingress controller because we will need the ingress to then create routes to get the hipster shop. And we are going to use some traffic to generate logs with the help of K6. So K6 needs obviously to know where to send the traffic to. So that's why we're going to use the hipster. So make sure to deploy. We need to get the IP of the load balancer service generated by the ingress. And then with the IP address, we will update the manifest file for the hipster shop with the right ingress and a name. And then the K6 load test needs to point out to this to the new URL. Once that is modified, we need to deploy Prometheus. Like explained, K6 will push the data to Prometheus. So make sure to deploy the Prometheus operator. Once it's done, you would need to deploy hipster shop, and then use this command to deploy the Fluent Operator. In our case, in a namespace called KubeSphere logging system. The other thing that will be required is that we are going to use Dynatrace. So if you have a Dynatrace tenant, you're good to go now. If not, then don't worry. You have to go to dynatrace.com, click on free trial here, and you can request for a free trial. You will get an email with your tenant. And once you get the email from the tenant, there are a few things that you will have to put outside because we need to configure one of the components that will help us to interact remotely with Dynatrace, which is called the ActiveGate. And within the Dynatrace, you have a link here. So for my case, it's a dev URL. But most important, you will probably have a URL with the .live.dynatrace.com. So keep in mind that it's the environment URL. So put this side of this, and here you have a number in front of that. This is the environment ID. So make sure you get the environment ID as well. Other things that is required, because we are going to send some logs to Dynatrace, we need obviously an access token. And that access token also needs to be configured with specific privileges because we are going to basically deploy an ActiveGate. And this needs to be, we create a Docker registry token for that. And there are a few things that you need. So I'm just going to show you, I already have it, but test, so that will be just for you, the sake of the exercise. But you will have to search for two different rights. The one that will help us to deploy the ActiveGate. So it's related to pass. So you can type pass here in the search. So that will give you a pass integration to install down and support alerts. You will have to click on those two rights at minimum. And then once you have those, the only thing we need is we are going to send some logstream to the logstream API of Dynatrace. So we will type just logs. And you can see here there is ingest log, so I can click on this one. So those are the three minimum rights that will be required. Once you have it, you can click on generate, and it will show you the actual value of your token. So please copy it somewhere because you would need it want to go further in this tutorial. So that's for the Dynatrace side. Once we have the Dynatrace, something that's important to attach the ActiveGate will interact with naturally with the Kubernetes API to register the new cluster. So you need to attach the cluster ID. So grab the cluster ID. We will need it later on in the Fluent Bit deployment. So update that file as well. And then we will jump into the actual deployment of the ActiveGate. So you need a specific service account because we will interact with various objects of the cluster. So it's going to be a cluster role with interacting with various objects, the pods, the daemon sets, the nodes, and so on. So like I said, we need the environment ID, environment URL that I showed you without the HTTPS. We need the cluster ID that we have collected through the previous command, the value of your API token, and the environment ID. And with this, we will create two secrets, one with the Docker registry to let the ActiveGate image being pulled out from your tenant. And then we will also need a specific token to interact with the API of the log ingest API. So this is two tokens, one for the Docker registry, one for basically interacting with the URL. Once you have all those values and create the secrets, make sure to update the various file that I show you. So cluster output, we will use it later on. The ActiveGate needs those values to be able to pull out the image and configure it and register to your tenant. And then of course the API token. So let's see what you should expect in your cluster. So let's see first kubectl get pods to see the pods running on the default namespace. In the default namespace, I will only see the pods and services related to the Prometheus operator, so the node exporter, the kubeset metrics, Grafana, alert manager, and the Prometheus server. So that's the first thing that you need to be aware. Second thing, you see that we will see the ingress controller deployed. So it's important. And if you do get SVC, you will normally see the API, the external IP address of your ingress controller, and this IP address will be used to update the various ingress rules. you'll see that I have all the various pods, services related to the heap job running. Those are there. And last, so now we can see that I have the load generator running. I may have to restart it because the pod probably the test has been stopped. So I will restart it, make sure to restart and make sure the test is running. So then you will have logs produced, and we will basically spend the other part of the tutorial looking at the logs from the Fluent Bit perspective. I already have deployed my Fluentd operator, and if you have not deployed Fluent Bit yet, the first piece of Fluent Bit, I will only use Fluent Bit, by the way, in these tutorials, not Fluentd. So you can see that I'm defining a Fluent Bit object. I didn't change much. In fact, I'm just referring to a configuration name called Fluent Bit config. This is important because then, of course, your cluster Fluent Bit config needs to have this name because your Fluent Bit deployment refers to that. So here is the Fluent Bit config. I have already implemented few labels for the input, for the filter, and the output. So those are the labels that I will have to add in all the various steps, input steps, filter steps, and output steps. So now it's enabled true. If I want to remove one of those, I can just edit one of the cluster input or filter, whatever, and change the value to false, and this step won't be used anymore. As of now, in this Fluent Bit, this has been deployed, so I only have very minimal stuff in this pipeline. I have a cluster input. This one is going to basically collect all the container logs on the cluster. So it's interact with on the node level, collects all the logs from every pods, all containers. And then I have another input where I want to collect kubelet data as well. So I have a path to the file, and basically here I just followed the steps from described in the Fluent Bit, the commutation. I have just done one filter on the kubelet. It's not perfect, but we will help it do. And the only thing that it's currently doing at the moment, it's pushing to std out. So you can see here it's the cluster output std out. I'm using JSON stream for the Kubernetes files and for the kubelet files. So let's have a look at what we get. So if I do a get cluster input, so here you can see that we have the object name, a new CRD name. So if I do this, you will see that I will have the two inputs that I referred to, the tail to collect the logs from the containers, and kubelet on the one on the kubelet. Other than that, I can look at the filters. So here I have only a kubelet filter. I don't have the other one. And I will explain how we could build the pipeline for that. And last, we have the cluster output. And you can see that we have mainly the std out. Let's have a look at the pod. So we have several pods here. So let's check one of them. Pod. So here is the log. So we are receiving a lot of logs. Let's have a look at the format of the logs. So we have different logs here. So the log starts from date. So here you can see that we have the logs starting from here. So date, log, error. So here you can see that the content of our logs is stored in log. And then we have the various stuff. We have a file name and so on. So at the moment, we don't have much information about the labels related to that pod has produced the logs. So for that, we are going to adjust our pipeline. And for this, we are going to use a cluster filter. So for this, I have started by creating a small cluster filter. And this cluster filter is going to be only applied on the logs coming from the container logs. And here, what I want to do here is to add the Kubernetes metadata. So for this, I didn't change much. I rely on the configuration that is provided by the Fluent community. and I'm asking to add the labels and the annotations. So it's going to basically interact with the API and add all the things related to that workload. So let's apply this one. So it's called, let's say, Kubernetes filter. So now I'm applied. So now if I go back to the pods of Fluent Bit, so let's take the same one. So this one, you will see that I didn't do any restart. So I can basically retake the same pod ID that we had with the logs and look at it. So here you see the operator has applied our changes, and now the logs that we are producing is different. So let me make a pause here. You can see here, this is a log stream. So starting from here. So this is an entire log stream that we've been produced. So the only thing that we have here done here is just add the Kubernetes metadata. As you can see, we have a label field here. That's basically, first we have a Kubernetes object, and within that Kubernetes object, we will find the pod name, the namespace name, the pod ID, and then we go to the labels, all the labels attached to that workload. So for the component, the app, and so on. And then we have annotations. And so we could also rely on those annotations. And last, we also have the host, so the node, which node is hosting this information, the container name. So in my case, if I want to push the logs to Dynatrace, I need to change slightly the format because I want Dynatrace to consider the new information to index properly the logs. So here, what I need to do is to basically take the Kubernetes objects and change it to push at the root level of the log stream, the pod name, the pod ID, the namespace, and various labels. Modified file. So here, lift will take everything that is under Kubernetes and put it up, and all the new properties will be named Kubernetes underscore. So we have, for example, Kubernetes underscore pod ID, Kubernetes pod name, and so on. So let's apply this file. We can see now that we have new property name. So Kubernetes underscore namespace name, Kubernetes underscore pod name. So now those properties has been properly set. So now we could basically, we have everything at the same level, except that, remember, we have two object label and annotations that are in a specific file format. So we need to adjust this. I'm using, again, I'm taking what is under Kubernetes labels and I'm lifting it up. And those will have specific naming. I don't have to change it much. As you can see here, the components, those are the labels. They have been, so the update has been done. So next thing that we have now we have everything on the right level. I need to rename few fields to use the right names that I need to index properly the data in Dynatrace, so which is here. So at first I remove the field called stream. I don't want this one. I remove the container hash. I don't need it. And then I'm going to rename. I may rename message into content, if there is a message field, log into content, date into timestamp, and then pod name is Kubernetes pod name. Kubernetes namespace will be renamed into Kubernetes namespace. Kubernetes pod ID is going to be Kubernetes pod UID, host, and so on. So basically we can do all the changes that we need. And I'm adding also a Kubernetes cluster ID because I needed to index it to the right cluster. Let's apply this one, and you will see that I have made some changes. Here it is. And like I said, now we have to wait a few minutes that the pipeline has been basically taken by the operator. And once we see that, you will see that there is a reloading of the configuration, and we will see everything running. So not yet, because you still have the Kubernetes pod ID, but in a few seconds, we will probably have the changes. The next thing that we will probably need to do, so let's wait a few seconds until it happened. We will need to remove a few unuseful information. And this for this, I'm going to use Nest first of all, and Kubernetes pod ID, Kubernetes pod namespace. So those has been renamed. So you see, I'm modifying the structure of the log stream. So the first thing I'm doing here, I'm taking everything which is under Kubernetes underscore. I nest it under Kubernetes, and then after that, I'm putting everything which is named Kubernetes underscore is all the fields that are needs. And once it's been put it down to that object, I can delete the entire object. So that will basically remove unuseful information for my pipeline. And then I have prepared another file called the cluster output HTTP. And I use a throttle. So because I need to send my logs into a bucket of less than 1,000. So I make 800 here. But you can reach out to 900 or 1,000. And then I'm using the cluster output called HTTP. So I'm using the HTTP plugin for only the Kubernetes logs. And here you can see that I will interact with the active gate that we've deployed. I have the environment, you have to, of course, this needs to be replaced with your tenant. I'm going to push that to this URL. This is the port of the active gate. I'm going to send it through JSON streams, and then I need to add some headers. So the API token, the content type, and I don't need to verify TLS because I don't have any specific certificate. So this basically you can once you have the right details, we can reapply it. I will go to the log viewer. So here you have logs. And here I will see all the logs coming in. So I don't want to look at the last 24 hours or 2 hours. I want to see the last 30 minutes. And I may have a couple of information coming in. All right, so now if you look at this log that comes in, you can see that comes from the easily observable cluster. And you can see that there is information about namespace. So basically it has registered all the logs related to the right entities of Dynatrace. So I have the few information about the cluster, the pod template, a couple of annotations. So it basically map all the right data. So then here I have already the Cloud application instance. So it helps me to go to the right screens. The logs will be attached to the right screens. So it's just perfect. It ingests perfectly the data that I was looking for.
That's it for today's episode related to the Fluent Operator. As you can see, the Fluent Operator introduced a lot of new CRDs, helping us to manage the deployment, the design of our pipeline, and I really like the fact that we don't have to restart all the pods to take advantage of the fresh new updates on our pipeline. I also like the fact that the new CRDs make the design of our pipeline in a much more easy way and in a standard way between Fluentd and Fluentbit. The only disadvantage at the moment from my perspective is the fact that we are not able to add extra plugins, so we'll have to be patient to let the community add all the plugins that we need or that we desire to build our logstream pipeline. If you enjoyed today's content, don't forget to like and subscribe to the channel. Thank you for watching and see you soon for another episode. Bye.